Cell.
To sell.
Yeah! Hey everyone, welcome back to Cell to Cell. My name is Heem, that's Nick. And today we're actually going to be reacting to Twitter feeds for medicine.
We're going to react to hashtag #MedTwitter and be looking at some memes, be looking at some cool maybe surgery videos. It's just going to be a quick video, just kind of fun breakup. We've been doing a lot of like technical stuff with like technology and medicine, and we had Yifan on, and we had a lot of kind of hardcore stuff. So let's consume social media like we all do best.
Yep.
Like, I wonder what this is. Okay, hashtag placenta people. Here's how you do it. Now go out and gross a bunch of placentas. Okay.
Hashtag petty path.
I don't know
Twitter.
what is. I don't know. Oh my god,
Okay.
That's a placenta. Okay, placenta. Okay. Do people eat those?
I do know people eat those.
That's crazy.
You know, I've seen some Twitter videos and
Cut a nice long strip. Okay, there's like the membrane. Huh. We should probably put a disclaimer at the beginning of this video. Probably should. Wow.
Oh, so she literally separated
Yeah.
parts out.
Nice and firm now.
Dude, this is a crazy video.
Yeah, this is weird. Roll up carefully.
I'm not sure if this should even go up.
Okay, next one. Got my Adderall prescription. Though he warned of a shortage. No, okay, alright, this is cool. So digestive process. So we're looking at, we're going to restart it. So food goes into the stomach, it gets churned into chyme, goes into the small intestine, the small bowel.
Look at how long that is.
Yeah, there's a lot of movement. So the point of the small intestine is to absorb all the nutrients. The point of the large intestine is to like reclaim like water and stuff, which I think is really cool. But then it goes through the colon all the way around. You can see that it is nice and brown and solid.
This is called peristalsis, by the way.
Yes.
When your food is being pushed through by your intestines.
That's a really interesting video. Let's see what else. We probably should watch that.
Do you want to look up hashtag
Oh, this
stem
one's
cells?
really cool. Okay, I saw this one earlier today, and this is on a cadaver, and what it's showing is when you are moving your arm like this, it shows how your scapula or like your shoulder is like moving with the latissimus dorsi. So like it's actually like under this muscle, and like it moves your back as you move. So like it doesn't like let you like, I guess, like throw your shoulder out of socket every time you put your arm above your head. So you can see how it like is getting caught by the lat and how it's like connected, all the way up. How cool is that? I saw that on golf Twitter. They were using it as an example to show like I saw on
I wanted to hashtag stem cells.
But they were using it to show like how you can like turn and how like your back works with your arms, and it was really cool. It's super cool. Trying to think. What else? Stem cell differentiation. I don't know how much we're gonna see. Just look up like cell differentiation. Oh, here we go.
So MSC.
Human mesenchymal stem cells differentiating into a neuron.
Now this is the type of Twitter
That's
videos that I wanted to
interesting.
see for this. This is great. Like you get to just see
That's really interesting.
real stem cells. Like this is like the true science,
So this is like, it looks like 15, 16 hours.
So you see these long lines. These are called processes when you're talking about neural stem cells or neurons. So neurons will have a lot of these arms, and these are called processes. And it's like morphology. Look at the physical features to see sometimes how far differentiated you are down the.
Yeah, that's really cool.
Yeah.
What else do we have?
Drosophila.
So this is fruit flies.
Yeah.
That's the same video we just saw. Students exploring while learning about stem cell and stem cell differentiation.
Well, they're playing a game?
Yeah. I want to know what game they're playing. I'm going to play. Oh, this is a good one.
iPSC.
So
Oh,
BMP4 induced human stem cell differentiation. So this is like probably from a developmental lab, but you can see how they have like the endoderm, what is that? Pluripotency, mesoderm, and the composite. So the composite's like all of them together, it looks like. And then they split them up into the different types of cells. So you have embryonic stem cells, and they pick 3 lineages to go down, depending on like what different factors are around them. So that determines like, oh man, my biology teacher's gonna be mad at me because I can't remember all the parts of like a fetus, like what it turns into. But I know there's like a neural like line that turns into like your spinal cord in your brain. Then there's like the ectoderm and then the endoderm.
Mm-hmm.
Pretty cool. That's pretty cool though.
Yeah. Yeah, another neuron.
This is another neuron. This is another cool video.
Amazing.
Nano Live looks like really cool use of technology.
I think what's really interesting to understand is like, so a lot of the protocols that we use in the lab were based on just numerous amounts of scientists looking at like the temporal aspect of all this differentiation, because it really does even take time. If you put too many proteins just trying to differentiate the cell, I don't know, that doesn't always give you the full differentiation.
Hold on.
It's kind of like you have to give it time to differentiate and let it go into its lineage.
All right, this is a really cool video. So videos like these make us proud. So these neurons have been cultured in some specific plate by Dr. Moreno and published in the lab on a chip. Differentiation of neuroepithelial stem cells into functional dopaminergic neurons in the 3D microfluid cell culture.
Oh my god.
That's so... I'm going to turn this sideways. Well, that'll screw up the video. That is so interesting, though. How, like, it looks so kind of natural how they all, like, twist next to each other. I'm sure they're all connected, too. Can, like, communicate.
Yeah. Organs on a chip, man.
Yeah.
It's the future. It's how, like, we're trying to simulate.
I wonder what the one quote tweet is. Yeah, beautiful neuron science. This is old. 7/25/18. That's old.
This field is developing.
Microscope building, a new spatially offset Raman spectrometer. We had one of those in my undergrad. So the intestinal epithelium relies on stem cells to drive constant cellular turnover, which is true. Very, very true. But it must balance stem cell division and differentiation in order to maintain homeostasis. So too much differentiation, you're going to cause tumors. Not enough, you're just going to have the acid and all the nutrients eat through the walls, and you have, what are those called? Oh my gosh. When you have like a hole in like your stomach.
Necrosis?
No, it's necrosis is like dying tissue. This would be like an ulcer. An ulcer. Like you would have an ulcer in your intestines. So too much division, you've got yourself a tumor. Too little, and things stop working. So this is a really cool video just showing how these cells, so the red cells are actually like columnar epithelial tissue, and like they're really good at letting things diffuse across their, it only goes one way, because like you don't want stuff going back into the stomach, or like at least right here where you're absorbing things. So yeah, this is a really, really cool one. How you can see literally how the cells are like jumping around and moving. And remember, this is just like 2D. This is all 3-dimensional. This all happens in 3 dimensions, and that's important to realize. Like cells are not just like flat like paper. They're very much 3-dimensional.
And they're touching cells in front of them, behind them,
behind
to the
them,
left,
everything.
right, up, down.
Wow. It's another like look at a cell culture.
I actually sat on this one talk from someone here at Case that was developing induced pluripotent neural cells, and then they would use eStim and they had induced pluripotent muscles, and then on top of that they put induced pluripotent neurons. So the entire model was induced pluripotent cells, and then they'll put eStim and stimulated the muscle and caused it to twitch, and the entire model was based on iPSCs. So I was like, that was so cool.
Yeah, I mean, I think we're really just kind of getting to like not the end of it, but like we've seen most everything. It's a lot of like nerves and like.
Yeah. That was cool though.
Yeah, it's interesting. You get another switch up, something
Yeah.
Something easy.
Something
And
light.
easy to digest. And if you are interested, please go on Twitter, go on Instagram, look up this type of stuff. There's all kinds of content out there that you're able to consume if you want to learn about this kind of stuff. So, all right, Heem, you got anything else?
That's all for me.
All right, well, thank you guys very much for watching another episode of Cells to Sell. My name is Nick. That's Heem. We'll see you in the next one.
See ya.